Topic of today's talk is added value and increased organization, capturing experimental data provenance in Materials Commons 2.0. I'm Tracy Berman. I'm a staff scientist working in Professor John Allison's lab at the Material Science and Engineering Department at the University of Michigan. And I think this particular meme is an excellent example of what we don't want it to look or feel like when we're trying to explain where our data comes from. So instead of keeping track of your materials information and data with a pinboard and yarn, I'd like to suggest Materials Commons 2.0. I've been working on the Materials Commons Steering Committee for about 5 years now. And this talk is from the perspective of an experimentalist, and I have a desire to have a better way to store and share my data. I'm going to describe the challenges of capturing experimental metadata, the approach Materials Commons uses, my process for using Materials Commons as an experimentalist, what I get out of Materials Commons for my time invested, and remaining challenges, particularly around collaboration and discovery. Materials Commons is one of the 3 thrust areas of the PRISM Center, the Center for Predictive Integrated Structural Materials Science. The goals of Materials Commons are to provide a place for collaboration and community, to house experimental and simulation information, to provide seamless continuous workflow, to allow provenance tracking, and really what we want to do in the PRISM Center is accelerate model building and validation on collaboration between experiments and simulation. And so in addition to myself, the primary people that have been working on Materials Commons for the past several years are the PI, John Allison. Glenn Tarcia is our lead developer, and Brian Puchala is the computational or simulation domain scientist. So he interfaces with Materials Commons a little bit differently than I do because I primarily use the GUI. So this is what Materials Commons 2.0 looks like now. It functions as an eLab notebook, a collaboration platform, and it also has a public data repository. So you can choose to keep your information private and then publish it when you're ready to do so. Materials Commons 1.0 was launched in August of 2016. We then completely revamped the site in April of 2020. We have over 650 registered users, and this is much higher now, greater than 15 terabytes of data, several million files uploaded. Materials Commons strives to follow the FAIR principles. So we make the material findable by allowing you to assign a DOI and having the data and well-described metadata associated together. You can also find Materials Commons datasets on Google Datasets. It's accessible, it's DOI retrievable. If you have that DOI, you can link it in your paper. It makes it easy for people to find your data. Interoperable, so it has a fully featured command line interface and API. And the data is reusable, so we allow you to provide data licenses. Hopefully the data is well described enough, and so it can be repurposed. We also strive to make it sustainable, and so the Materials Research Institute at the U of M is providing for funding for long-range storage. We strive to make it easy to use. We want you to be able to organize and view both experimental and simulation data. There's documentation and training both through the website, and also there's a PRISM Center workshop held annually, and then we'll be adding some more YouTube tutorials. You can upload and download the, information using the Globus interface. This is helpful if you have large data sets. And then we're working on Materials Commons communities, a place that we can really have awareness on needs for standards and curation. And so we all know that capturing experimental metadata is very challenging. It's a very inhomogeneous landscape that material scientists work in. And so I've gone to several workshops and conferences where we discuss those challenges. And kind of 2 main approaches have been suggested. One of the reasons that it's hard to capture the data, though there are some works in autonomous labs, is it is hard to automate some experiments, and the responsibility of capturing the metadata really falls upon the students, technicians, and scientists in the lab. I refer to these as data generators later in my presentation. And so there's kind of 2 approaches. that people use to try to get metadata in. One suggestion is auto-ingestion of data from instruments. Complications to that, or the instruments aren't always online. This could be because of security reasons. You might have an outdated operating system, so you're not allowed to put the instrument on your network. In addition, not all data is useful, and so you really risk clogging up your database with lots of data that may not have much value. And reasons that it might not have much value is you could have poor sample prep. You'd have a very scratch sample that's not easy to do microscopy on, for example. And you can also have poor experimental setup, and so the instrument cannot have the right conditions to really capture the information that you're looking at. And so here is a micrograph. We were trying to look at grain boundaries in a raw aluminum alloy, and the student accidentally had the optical microscope on dark mode, which allows you to see some of the precipitates a little better. It's very difficult to look at the grain boundaries. In addition, you might have a whole bunch of optical microscope images that are white balanced properly. So that makes them a little harder to reuse. And you might not want all of these in your system. Another approach to capturing metadata is to require the users to fill out a form to start a session. Problems with this are you can't ensure data quality. The technician in a rush could just put in bad or useless data in those fields to progress through. Also, there could be an error. They might be trying to do their best, and they type in an error. Where does that information go? Can that user, the instrument user, easily fix the error? Is it just going to propagate down into your metadata? Can the user access the information that you made them type in? Is there any value to them for doing it? Or is it just something that they have to do? Really, like, there needs to be a benefit to the user that they can see and realize. So why is it so hard to get data generators to record metadata? I'm not a human behaviors expert, but I am a human, and I really love listening to the Hidden Brain podcast. And I've pulled a few common themes from that podcast about how our brains work and applied it to capturing metadata. One issue is that humans are not very good at predicting or preparing for the future. We predict that we're going to remember what we did in the lab today. If you're a student starting on your first sample, you very intimately working with that sample, you can't imagine the time that you're going to forget what you've done to prepare it. 4 years down the road, when you go to write your dissertation, you've most likely forgotten. But it's just hard for us as humans to anticipate that. We think our memories are better than they really are, which creates lots of problems for us. And lastly, we're creatures of habit. Really, we're going to keep doing what we have been doing. Willpower is not the most effective way to achieve long-term change. So just telling someone that they have to put it in isn't really going to change their behaviors or change their habits. So what we need to do is lower the barrier to reach the desired outcome, which is including and recording your metadata, and maybe make it a bit harder to reach the undesired outcome. Disincentives for not recording your data properly. So this is the only screenshot I'm going to include from Materials Commons 1.0. But what we found in that first release of Materials Commons were that rigid requirements for metadata make the barrier of entry too high. And you're not going to get people to put their data in. They're not going to see any value. And so what we did in Materials Commons 1.0, and you might be able to see over on the right side here, is we had very rigid templates for the type of metadata that was required. We had very specific processes that we kind of had to curate and have in the system. So a group of people had to come together and decide what's the valuable metadata to record. And the problem was that this was very inflexible. If you wanted to perform an experiment a little bit differently, make some changes, innovate on the experimental process, then you would have to petition for a change to have a parameter included. The plus side was that relationships could automatically be mapped out. We could create these trees that link behavior and attributes, sample attributes that might have been changed. But because the barrier of entry was too high, there just wasn't any data in the system for it to get mapped out. And so we wanted flexibility to incorporate improvements and innovate new processes on sample analysis techniques. And so we're now transitioning into Materials Commons 2.0, and we use an ETL or extract, transfer, load spreadsheets in order to get data in from the system. And we moved to this because a spreadsheet is a very common way for experimentalists to capture data. and format it in a way that works best with your workflow. And so each sheet within the workbook is a different experimental process. You can see I have received samples, heat treatment. It's really easy to expand your experiment by adding a new sheet or to remove something that's no longer relevant or move it into another workbook. Column headers can be the sample name, a sample attribute, which is a measurement, a process attribute, which tells you something about the conditions of the process. So that would include metadata. Could be materials conditions, it could be a file folder name, a note, etc. The nice thing about this is that it's very easy to update if a collaborator has a suggestion for an improvement. If they don't like the name that you picked for one of your process attributes, all you do is have to change it within your spreadsheet. And then next time you upload it into Materials Commons, it will propagate all those changes through. Of course, the downsides of using this spreadsheet that's easy to modify is we don't guarantee data quality. We don't guarantee machine readable data, but it really lowers the barrier of entry. And so we can get something into the system and then hopefully people will be motivated to have their data reused and they'll make edits so that their data is more valuable to others in the future. And we really hope that having a communities of practice will really guide data generators and how to set up their spreadsheets. And I'll talk a little bit more about that later. My suggestion is to update this spreadsheet in the lab as you work. It's experimental lab notebook. Do not do it later because you're going to forget and it's going to become a burden. If you keep the spreadsheet on Google Documents, it means you can update it anywhere without the internet, and it ensures that all collaborators are working on the most recent version. And so I have undergraduate students that work with me, and so we'll share a Google document so I can see what they're working on and suggest revisions very easily. Another one of my suggestions is to make transferring data into Materials Commons 2.0 part of your routine. Make it a habit so it gets in there. And so Materials Commons has a file directory system. First, you would want to upload your updated ETL spreadsheet. You can just download that off of Google Sheets if you need to, or move it from your personal computer. And then upload all the files, relevant files from your flash drive or the instrument server. Now I always upload them first into Materials Commons before I put them on any additional analysis personal backup computer or backup location, just as a reminder to myself that they have to be on Materials Commons before I do anything else with them. I also suggest the third step of deleting this data from the instrument server under flash drive, just because multi-user facility servers tend to get filled up faster than you'd think they would. So just as a housekeeping habit you can develop. I then suggest that you reload your experiments on a regular basis. So remember, you need your current ETL spreadsheet, your most recent and updated ETL spreadsheet. And then you would go into the experiment and just click reload experiment. And I schedule this as a weekly reoccurring task so that I know that the information I have in Materials Commons is the most up-to-date version. If you go into the experiment, you'll see there's a page, a spreadsheet load logs. And so that gives you a summary of all the processes and samples that were created. And so if you go in that, you can view any particular log. And so here, if I open this log from 3 weeks ago, it would display everything that was created in the experiment. But if you type error in the search log, that helps you find any problems there were in setting up your experiment. And so usually I do this because I find out I forgot to add a file to Materials Commons, or there's a typo in the file name. And so I can just copy all of these errors and go down them as a checklist. Probably just forgot to upload that particular folder. And so it's a really good check for me to make sure that everything that I think is relevant is uploaded into Materials Commons. And so I just suggested that you should be dedicating a lot of regular time to recording metadata and uploading information into Materials Commons. And so then the question is that investment worth it to the data generator, the person collecting the data in the lab? Have we really provided an incentive towards that desired behavior and the good habit? And I really think we've reached that point with Materials Commons 2.0. I've used Materials Commons extensively in the weeks leading up to preparing for the TMS conference this year for my technical talk. And so at this point, I'm going to transition into the value that I get out of using Materials Commons 2.0. One thing is that it's really easy for me to remember what I've done to a sample. And so if you go into the samples page, what you're going to do is get a chart where each row is a sample name and each column shows processes. And if that process has been performed at least once on a sample, then there's going to be an X there. And so what I've done is searched for ZX21, which is the name of an alloy that I'm studying. I prepend that to all my sample names. And so I now have a list of all of the ZX21 alloys I've studied. And if I need to do a texture measurement, it's easy for me to see. I haven't done it yet on this sample. If I click on, for example, the sample right here, the ZX21_5 minutes DO6RX, this brings up materials data cards. And so this view is my favorite part of Materials Commons. I'm not searching through reports or files or old presentations to remind myself what I know about a particular sample. I just refer to these process cards. And so for each process, I make sure to link files that I would most likely like to see to summarize the sample in my spreadsheet. So I like to put images that just give a quick visual summary of the material. And so here I've got information about where I received the material from on its composition. And then I've done some texture measurements using EBSD. And so I've got the files I've used to generate these, as well as inverse pole figure map and the pole figures. So I have a quick visual on the texture intensity. I've done some Global thermomechanical processing. And so there's a short summary of the processing attributes, as well as the QHD file. So that'd be the instructions. If you have your own Global, you could use that same file to process your sample in an identical way to how I had processed mine, as well as the raw output, which includes stress strain response. I've performed a heat treatment on this particular sample, and then I've also done some additional EBSD scans looking at grain size and extent recrystallization. So this is all really easy for me to find as a reminder to myself. And more importantly, I can share this same sample view to share information with the collaborators. If I'm handing off this sample to someone else, I can just say, hey, look this up in the Materials Commons. This is a quick summary of everything we know about it. If you want to see the grain size, I've probably already looked at it in there. If I'm in a meeting with my PI or a collaborator, they have a question about how a particular processing variable affects the texture or grain size, I can quickly bring up the sample view and Materials Commons so we can discuss it instead of me spending time searching for my computer to find the presentation that I've already summarized that data in. However, sometimes I also forget what processing variables I've already changed in the past, particularly in less recent work or in experiments where I have quite a few samples. And so this is where the new query builder comes into play. We're working on a sample query language. And right now it's a little unwieldy, it's a beta. And so we're trying to make it a little easier to use, but it's still quite useful. And so in the query, I've searched for all samples that have the Global process, samples where I've done greater than or equal to 3 deformations, and only samples with the ZX10 alloy. And so you can see 2 samples meet that criteria. So I know that I haven't done much work on the ZX10 alloy, actually. Another benefit I found to using Materials Commons is that it makes it easier for me to compile monthly, quarterly, annual reports. Part of this information I don't explicitly need Materials Commons for. It's in that ETL spreadsheet, particularly the date field, the date I've done a particular process, but it was the act of constructing that spreadsheet for Materials Commons that imposed that extra organization on me and consolidated everything into one place so it's easy for me to find. In addition, if you open up a project or an experiment in Materials Commons, you do get a summary of the number of samples, the number of files, the different kinds of processes that have been performed. And for some reports, they really like that, the file size and the information generated. And so it's really easy for me to include that. Really easy for me to check, for example, what I'd done in July. Once I have a publication accepted, I can choose what samples and files I'd like to be publicly made available. I'll collect that into a data set, and provide a DOI assigned through Materials Commons, put that in the paper. So that makes it really easy to link the final project, published project, with the original data. So it's easy for me to associate the data with my publications. These data sets can have the licensing option of your choice, and anyone interested in the information can download the entire data set. There's a zip file, or you could also navigate to the Files tab and download the individual files of interest. More importantly than just associating your data with the publications, there's actually context. And so you can go into the same sample view that you could in the private site. You can see the samples and which processes were performed on it. You can go to those sample cards that I showed you earlier that I really enjoy for the quick visual. It shows how all the files are linked to the sample. And you can also build a workflow that quickly summarizes the experiment. So you see the variable in this experiment was whether it's an yield or not. And then I was using EBSD to compare the two sample halves. And so in addition to providing that context and metadata, hopefully facilitating reuse of this data, I know the data is backed up and it's available for future use. It should be findable in Google Datasets and on that public-facing Materials Commons site. However, there's still a lot of remaining challenges, particularly around the collaboration, discovery, and use. It does require a time investment to develop an understanding of the project. And so things that we've done to lower that time investment are the query builder, which I already mentioned. But also if you go into experiments, you'll see there's a sample attributes page. And so that provides kind of a data summary of the different attributes. So if grain size, you'd see if that's something that I included in here, or process attributes. And so if there's temperatures, you could see the range of temperatures. It'll show the minimum, maximum temperatures to give a little bit more summary and context of what is included in this experiment. Another challenge is keeping track of ground truth. We all know that experiments evolve, they branch out, things are shared. Because we do each experiment is an ETL spreadsheet, if you include a sample in multiple ETL spreadsheets, then you can't ensure both are updated and accurate. And so that provides a question of which one is the most accurate. Obviously, you could trace when the date is, but it becomes a little complicated. And so my suggestion for this is when you compose a data set, you can actually include samples from multiple experiments. And so I would keep each sample in a singular experiment and then have data sets kind of bring things together in the future. And you can always move a sample from one experiment to another if it's more appropriate. Just make sure it's only in one place. And finally, I hinted on it earlier, but really with our flexible process, we have a lack of standardization. People could be using different units. They might not record all relevant process attributes or might not record them in a way that's useful because we have no enforcement of the quality of metadata. So that's where we added community of practice into the public facing site. And these are places where data sets can be grouped together. You can add your own data set, for example, to this one on recrystallization and magnesium its alloys. But we could also provide a file, for example, a suggested ETL template to use or links to places that discuss better standards for how to record your data. And so we're really hoping that it's communities that come together and make this decision, because us making the decision as Materials Commons is not going to be the most useful for everyone else. With that, I'll end with a motivational quote and a summary here of how using Materials Commons 2.0 benefits me. The quote being, "The creation of a great data set begins with a single spreadsheet." I know it's significant overhead to get a previous data organized into the system. Compiling all into one place in that ETL spreadsheet, it can be overwhelming. And so instead of trying to do that, I encourage PIs and the people generating data in their labs to start making Materials Commons part of your routine today. Start with the experiment you're currently working on. You could start with one sample on a few processes. Once you get that into Materials Commons and start seeing how helpful it is for you to have this place to summarize and have a quick view of your data, I think you'll see the benefits of that, and then you'll be motivated to put in the work and say, oh, I wonder what this sample I should have in Materials Commons too, because I'd really appreciate being able to compare samples here. So I think there's going to be the driver for getting past experiment work into Materials Commons 2.0 as well. So it's a new day. We can create a new spreadsheet. If you have any questions, I can be contacted at my email address here. Thank you.